All right, on to step 2, getting our critical F value to define our critical regions. So remembering what we've already talked about here, everything's a one-tailed test, everything's a positive value, but remember the shape of this F distribution is positively skewed, so we need a new table for that. So for the next 2 weeks, for this chapter and the next chapter, we'll be using table B.4 out of your book, the F distribution. So this one is back to being a few pages long, but again, we don't have to worry about one tail, two tails, so that simplifies things there. So please go to table B.4 to find the F distribution. Pause the video if you need to. So looking here, we can see what this wants to know from us to give us the critical F. We need to know, as always, our alpha level. Are we at 0.05? Are we at 0.01? So that's one of the things we have to know. Now, if we look at this table, across the top here, it says degrees of freedom in the numerator. Well, let's look at the formula sheet. Degrees of freedom is one of the columns in here. And so we're going to get a degrees of freedom for between treatment conditions, a degrees of freedom value for within treatment conditions, and a degrees of freedom value for the total study. So the question then is, of these 3 degrees of freedom, which one is the numerator? Well, look back at what you wrote in your notes earlier about the F ratio. For our F ratio, we're going to have the between treatments values divided by within treatments, right? This is our error term. We just call it an error term now. We were calling it estimated standard error in our t-tests. It's just called error term. It's just simpler now. So numerator, denominator. So it wants to know across the top the degrees of freedom for the numerator. Well, then that's going to be our degrees of freedom from the between treatments column, because that's what's in the numerator. And then down the side, it says it wants our degrees of freedom for the denominator. Well, our denominator is within treatments. So then we also have to have our degrees of freedom within treatments. So these are the 3 things we've got to have in order to use this table. Now notice what that means. We're in sort of an awkward situation now, because to know what these values are, we need to do some of these calculations, but we haven't got to step 3 yet. So this is another little derivation from our normal procedures. What I do when I'm working through these, and therefore what I recommend you do, is get your prep work done, do your step 1, write out your hypotheses, get to step 2, write down your alpha level, 0.05 or 0.01, make a spot for this, make a spot for this, and then just write critical F equals and leave it blank for now. What you, in most cases, want to avoid, do not, what some students want to do instinctively, is they want to go ahead and jump forward to step 3, do these 2 calculations real quick, jump back to step 2, look up their critical region, and then jump back to step 3 and do the rest of the calculations. That's a recipe for disaster for most of us. That's too much jumping around. There's a lot to organize in this. There's a lot to keep track of, and the less jumping around you do, the better. So what I recommend you do is your prep step, your step 1, get to step 2, get it set up to write your answer in, and then just leave it alone and go to step 3 and do all of the math at once. Then go back to step 2 and look it up. So we are talking about step 2 right now, so I'm going to finish talking about it, but that's the approach I recommend, is you can't actually look this up until after step 3. But when you do, you'll look up your degrees of freedom from your numerator across the top, your degrees of freedom for your denominator down the side, and see where they intersect. So if we had, let's say 2 degrees of freedom in the numerator, and let's say 10 degrees of freedom in the denominator, so we'd go over to 2, we'd go down to 10, and notice that there are 2 numbers intersecting there. There's one in light face font, and there's one in bold face font. We can see a 4.10 in light face font, and we can see 7.56 in bold face font. The difference is the alpha level. And it tells you that right here at the top. Boldface type values are for the 0.01 level. And above that, light face type are 0.05. So you look up one value, look up the other, look at the two scores that are there. And if you're working at 0.05, go with the light face font. If you're working with 0.01, go with the dark face font. And notice that it is in two places. So once we're able to have this, we'll be able to report that our critical F equals some number. And as usual, we don't round tables, although we wouldn't need to on this table anyway. We just leave it in the format however we looked it up. And establish where our critical regions, where our targets are that we're aiming for. Like always, it's one thing that doesn't ever change here. Once we calculate our F statistic or F ratio, if it's in the shaded area, we're going to reject the null hypothesis. If it's anywhere else in the body, we're going to fail to reject. So it works the same way, just a little bit different shape. Ultimately, it's easier than most T because we don't have to think about one-tailed, two-tailed. It's just all one-tailed. So that's step 2. So next video clip, we'll start looking at the math.